his seven trips into space, Franklin Chang Diaz earned a Doctor of Science degree in applied plasma physics from MIT. Once he retired from NASA in 2005, he started the Ad Astra Rocket Company, where he's using his passion for plasma propulsion to develop a revolutionary new way to travel around space fast. Very fast.
These kinds of rockets are such that they keep accelerating all the time. In other words, it's like, you step on the gas and you never let go. A typical mission to Mars, for example, today, if you were to use a conventional chemical rocket, it would take you the better part of a year to get to Mars, one way. With our vehicle, we would do this mission in 39 days.
Today's fastest deep space rockets top out around 40,000 miles an hour. But Chang Diaz says Ad Astra's groundbreaking rocket, the VASIMR, will be able to break 120,000 miles an hour because it'll run on plasma. Using plasma to propel a rocket had never been attempted before, but the idea has been brewing in Chang Diaz's head for years.
When I went to graduate school, I began to learn more about fusion, about plasma physics, about power that powers the sun. I thought to myself, someday spacecraft will use this fusion power to propel themselves extremely fast and go faraway places in deep space.
Plasma is created when a gas is heated and the electrons break free from their atoms. Because of their extremely high temperatures, things that contain plasma, like the sun, lightning, and even your plasma TV, they all pack a lot of heat. A normal space shuttle exhaust gets to a few thousand degrees, but next to the plasma-powered VASIMR, that's earmuffs and gloves weather.
The hotter the rocket, the better the rocket is. And the problem is, of course, that you cannot have any kind of material structure near this hot plasma. Fortunately, we can hold plasma with a magnetic field. What that does is that it completely removes the plasma from any contact with any material. So we routinely generate plasmas that go up to over 1 million degrees. So this is our rocket, and it is now fitted, sitting inside this stainless steel vacuum chamber. In this vacuum chamber, with the door closed, of course, we're able to reproduce the conditions of space.
Because the plasma rocket will only work in the vacuum of space, the VASIMR will still have to be launched on a conventional rocket from Earth. And then, once there's no pesky atmosphere to interfere with the plasma, the VASIMR will be able to act as a super-fast system for moving supplies around in space.
A colony of humans on the moon is going to require the supply of fuel, food, and water, equipment, and all the necessary things that are going to be keeping that habitat operating. We can have almost the equivalent of UPS, where we can deliver cargo through your door on the surface of the moon.
For former astronaut Chang Diaz, this isn't merely a fantasy.
The view out of here is just spectacular. It's just gorgeous.
Once plasma rockets are able to shuttle people through space quickly, we'll no longer be tethered to Earth.
The Earth will maybe someday will become a national park, a place where humanity will always come back to, to search for its roots. I think that space is important because we're doing nothing less than ensuring the survival of our species. We have no